Well, g'day, Max here again. Welcome back to the shop. So, I think I've spent the best part of today and quite a bit of yesterday doing Josh Topper's favourite job, drilling holes. We are supposed to be working on our boring bar, which we are going to do right now. But yeah, I had to make a start on some of these jobs. You need to do this before you can do that, so you can do that. So I do my best, or trying to do my best now, to dedicate one day a week to spend on those jobs. And this is the sub plate that was in our radial drill, sitting underneath the big rotary table. So yeah, well, let's make a start and get this knocked off out the way. So I'm doing this off camera, but I'll show you where we're at. So amongst the pre-existing holes that are on here, we're doing a grid pattern of 16mm holes, which was all good. I started doing them at 50mm centres, as is a standard measurement for tooling that I make, M16 50mm centres. And then I decided, well, let's do another row in between, so that's just going to double my work, but we'll do it anyway. And I brought a new second-hand, new to me chuck from eBay, from the USA. So I thought I'd try out these Jacobs ball bearing chucks. This is a little 14N, half-inch capacity. And beautiful chucks, they work absolutely great, really impressed with them. I'm using it in a long adapter because it saves me having to wind the knee up and down for when I swap between drilling and tapping. So, and doing this gave me a good opportunity to test out my new tapping head. So I'll slip a picture of that in action, but this is said tapping head here. So it's just a Toolmaster brand, it's just a generic cheapy brand. They're average. They're not high end, they're not bottom end, they're in the middle. So this one here I picked up at the bargain price of $50 from our local tool supplier, who had it on their seconds. Oh, they have a bench, where things are cheap because they've got parts missing. So yeah, $50. It was just salt. They explained that it was rooted, the clutch was knackered, and so I thought, it's only a clutch. Who needs a clutch? So I thought, yeah, I'll take the chance. I mean, I can always bypass the clutch so it locks solid. That's not a problem. So I put it in, and we've been tapping away with a 16mm gun nose tap for through holes, and it has the clutch adjustment here, 1, 2, 3 and 4. We're just past the 3, and it's tapping these holes without a murmur. If I back it off, it's got a ball bearing type clutch in it, so they go kadunk, 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 kadunk when they slip, and it's working perfect. So I don't know what the previous owners were trying to tap. Mind you, its capacity is 20mm, and I haven't, this is the first time I've used it. So it's just a 16mm, so maybe it does slip on 20mm, I don't know. So, right, let's head over to our job at hand. So we're going to be using the Herbert turret drill, and we're going to start drilling some holes in the end of our boring bars. So we'll get one of these drills through as far as we can go, and then I may look at knocking up a drill extension so we can go in further and just see how we go. And the reason I'm using, one of the reasons I'm using this is because it's got more quill travel than my other machines. Ideally, if I did it in the Bridgeport, I'd either have to put a chuck on the table and overhang it, which isn't a problem, but we're still, I could do that, push comes to shove. Or you could mount it on the table and just flip the head around 90 degrees. Either way. But yeah, we'll see how we go in the Herbert. So I knocked up this tapered plug just to centralise our part. It has the same taper as the bore. And that just goes in there and make sure that we're on centre. So yeah, those are the centering plugs. I use them quite a lot, just easy to make up for different size holes. This is the one I'm using at the moment for when I have to shift and relocate our subplate for the other half of the holes. So that'll just pick up on a drilled hole with the chuck, and that way I don't have to lose my settings in the DRO, and we're centered back up straight away. And that's because for some of the holes, to reach them, I have to move the ram back. That way we maintain all of our measurements. Yeah, just a tapered centering plug. So we'll go through with this drill first, parabolic drill. It's an 8.2 millimetre. I think it's one of the ones that I think Rob from Dudley Toolright sent us over from the States. And then we'll follow up with this one, probably. Not sure what size this is. Anyway, let's get this one through first. Okay, first chips. Okay, I'll just go and get an airline so we can get some of these chips out of here. There's a parabolic drill, so they're really good for deep holes. Okay, we'll go some more. Well, that all went well. With these drills, I like to, with the way this is drilling, I like to keep the pressure on, keep the feed on rather than back them off. I mean, I could see it was evacuating the chips, no problems. What happens if you back them off, and I did a couple of times, a chip gets stuck under the cutting edge and you can feel it. It takes a bit for the drill to bite through it and continue drilling. Okay, so what we'll do now is we'll put the larger drill in and opening that up a bit more. Feel there's a chip stuck under the drill, it's not letting the drill bite in. There it goes. Okay, that's the end of our drill. Okay, so we'll get the next one to the same stage. That's it, full depth. Yeah, sometimes when you're drilling down and you pass the flutes, you've got to lift the drill to allow the chips to come out. And sometimes the chip will get caught between the cutting edge and where you're trying to drill, so the drill just goes round and round. And until that chip rubs through, the drill won't cut. So you just sort of got to regulate your pressure a bit and until it decides to start cutting. Okay. So we're down to about here. I'd actually like to go down a bit further, so then what we'll do is we'll make up a couple of extension drills so we can get right down deeper. Right, so these will be our extension drills that we are going to use. So I've made this tubing is Grineveld grease line tubing. So it has a small hole all the way through it, and that's to allow the grease. So they use this tubing on machines where they fit remote or auto lube style grease lines, and it's quite strong and to use on the machines. But I'm going to use it for extensions. So this drill here, I've drilled our drill. So that'll go up there, and we'll silver solder that together. And this one here, I've just turned down the end of the drill. That'll go in there, and we'll silver solder that one together. So this one will form our pilot drill. So we go in as deep as we can with this one up to that, till it stops. And then we go in with this one deeper, then that one. So we just alternate between the two. Now, if the drilling gets a bit too difficult, it's one that I made up ages ago. We've got this little one we can use. A couple of years back, and this is the one that I used to drill the oil holes in the JFMT's tailstock base. So that's on a very early video. Yeah, we had to do some very deep holes up it. Okay, so let's head over to the welding bench. We'll get these silver soldered together. Okay, we'll get our drill silver soldered into its extension. So I've cleaned these out with acetone. So we're going to be using Easy Flow Flux and BOC 45T silver solder. Let's get a bit of flux going on inside. and on our drill bit. You know, I'm very tempted to tin these first. Let's do that. I just want to be sure, because what we're welding to is, or silver soldering to, is very thin, and this drill bit's got a bit of mass to it. Yeah, that's got on there really well. I'll do the same with the bore. Okay, that's looking good. more flux. There she goes. Okay, perfect. That way we're sure we've got 100% bonding. So that come out well. Okay, that's the first one. Okay, second one. It's funny how when you look at the flame, it looks like I ignore that spurt coming off the side. On video, this is actually a neutral flame, but on video it looks, you can see that secondary cone. Yeah, the looks like a carburizing flame. Yeah, funny how the flames change on camera to what it actually is. And quite often too, things also, when you're using a flame to heat things, the part looks a lot redder and a lot hotter than it actually is. Get a bit of heat up into this. See, that's only a dull red just there. Yeah, it looks about the same on there, but yeah, quite often, yeah, there's just copious amount of flux on that. Probably just, I didn't cook it yet, so, okay. Plenty of flux. Bit hot at the end. Okay, we've got a nice coating on that now. We'll go to our other part. Bit of fluxing action going on inside our drill bit. Actually, I'll just melt the end of that off. There it goes. It's starting to get a bit shitty. think we've got a nice, starting to get a nice thin coating inside now. Yeah, looking good. Plenty of flux. Okay, just going to dip the other end of our other part in flux. Reflux. Reflux. Hopefully starting to sink down into it. Beautiful. There she goes. Okay. You can see the flux bubbling out the top of this one. These are rods that I'm using for the extensions. I think I explained before. They have like a 1.5mm hole all the way up them. So that means I didn't have to drill like a little tiny relief hole at the bottom. So we didn't get any air trapped and things like that. So I'll get these cleaned up on the wire wheel. Okay, end result. Very tasty. Right, let's get our holes. Well, we'll get set up to do our holes. So this will be our setup for drilling the remainder of the holes. So I have had to go this way because I haven't made up the mounts for the boring bars yet. If I had them done first, then I wouldn't have to do this. I could just put the boring bar in their said mounts and merrily drill away. So I've indicated this plate and lengthwise, so we're good that way. The other way doesn't matter where it is. So we clamp our bars to the plate. We'll put a drill chuck in the chuck and merrily drill away. Now, the other reason why I've gone to this method is we're going to need a lot of quill travel to cover the depth required for the length of this drill bit, and plus it's got to be able to clear the hole as well. So I do not have any machines in my shop with a quill travel of 2 feet, or 500-600 millimeters. Plus, doing it in a lathe here, you get a lot more feel than if I was to use the tailstock. So if I feel or hear any funky noises going on deep within the hole, I can quickly eject the drill from the hole. So that's the plan. So we'll get our boring bars mounted on our subplate here, get them centered, and start drilling. And just to support the weight of the plate and our part, we've just got it on these jacks underneath and locked into the tool post. Right, so our part will register against this face here, which I've indicated in, and we've already indicated our plate in. Now, ideally, we should have it sitting on a V-block, something like that. Would be the ideal setup. But since I'd already set the height of this plate, it's bringing us up too high. So we'll sit our part directly on the plate. And I'm going to use 2 clamps just pushed up finger tight. And that will stop the part wanting to roll away when our other clamps go on. So these just sit down in here. Just pushed up with finger pressure. Like that. Okay, let me just go and get the... No, I've got one here. Just looking for the right size spanner. Okay, just tapping there and then just to get... I was just noticing a little bit of rock. Okay, that feels good. So that tapered plug that we had when we set them up in the other drill, we make use of that now, and because we're eccentric here, all we have to do is rotate our part around till it slips in like that and we're on centre. We'll get you a close-up. Yeah, so all we have to do for alignment is just bring our part up. As we rotate it, it'll self-align on the taper. It's it there, right there. So then we can just set our clamps over. Something like that. If I can get the nut to start. There we go. sort of jigger them around a bit so they're sitting square and level. Like that. Okay, ready for drilling. Alignment feels good. Alignment, yeah, it's good. You'll hear it if there's anything funky going on. Beautiful. Yeah, so I want the light feel of the carriage. I can feel more what's happening with the drill over a winding in a tailstock. And plus, yeah, as I said, it gives us a quick, we can withdraw the part off the drill. So we'll get our first drill set up. Now the other thing is, we won't know till we start the lathe what's going to go on here. We'll see. Just going to give this bed a good oil up. So I'm really hoping we don't have to run this drill through a steady rest. Well, all we can do is try it and see what happens. Let me see what I can do. I'm going to have to rig up a different coolant spout so we can get the coolant directed up that way. Okay, I've decided to go with a steady rest just to stabilise the drill a bit, and I've also sat on our carriage stop. So what this is for, once we're drilling and I need to come back and clear the chips, I can easily come back and gently come up to where we finish drilling, and saves impacting the drill, well, saves the drill hitting hard deep into the hole. So it just gives me an idea, a distance of where we are. So I think we're all set. We'll get the coolant switched on and see how we go. That's on 350 RPM. We'll just see what 500 looks like. Okay, we'll go with 500. I'm just going to find out where the end of our existing hole is. So just very gently come up, which is there. Okay. So what we aim to do is drill about 70 millimeters, 75 millimeters, 3 inches of this drill. Then we take this one out and we put the larger one in, and the same, and we just keep swapping between the two as our drill extension is larger diameter than the drill. So yeah, we'll just keep stepping between the two, and we'll go in our part. I really hope we can get 3/4 of the length of our part drill. We do not need to go all the way through, as there is other features I'm putting on these bars on the end. So our coolant port, when it's drilled, will come in through the side of the bar, but let's see if we get that far first. Well, so far so good. I'll bring you back when we're a bit further in the hole. I put that little elbow on the end of the coolant pipe, and it's yeah, gets the coolant right up in there now, which is what we want. So let's get a depth check. So I'm at the end of the hole. Now we've got to pick up the end of the larger hole, which is right there. I can feel it. So we're in 70 to 75 millimeters, which is the bulk of the flute length of our drill. So we'll swap the drills over, we'll put our other drill in, we'll open the hole up, and then we'll go again with this one. Any misalignment, that'll soon true itself up once it's centered in the bore. So we'll just come up till we feel the contact. Which is right there. Move our carriage stop forward. Back off, and should be right to go. Yeah, I think that was out of the shot then, so our drill's bottomed out on the existing hole, so we just slide that back up, or back off a bit, and we know the drill will contact when our carriage touches the stop. Right, we'll check our depth. We're actually halfway through the bar. And we're caught up to our pilot drill, so I'll swap the drills back over and we'll pilot drill some more. It's actually all going rather well, but so far so good. Come down, try it there. Okay. So I just want to gently come up and find out our starting position. Which is right there. Okay, and away we go again. Okay, let's see where we are. I've actually gone deeper than what I anticipated, and I'm going to try and go full depth all the way through. We've got 10 millimeters or 3/8 of an inch to go. So I'll have to put the pilot drill back in, and we'll break through with the pilot drill. Unfortunately, this drill here is the exact length of our part, so I might just stick a little extension up it, and then we can push this the remaining distance, I think. I don't think we get it. There's we ain't got much in the chuck here. We need 10 mil. We're going to be gripping this drill on 1/4 of an inch to get a breakthrough. We'll give it a go. So in the interim, we'll get the other drill in and get our pilot hole all the way through. Okay, we'll get our carriage stop reset. Just bring it over a gentle so we don't smash the end of the drill onto the end of the hole. We're right there. Okay, back her out. Important to get that coolant right up the end. Beautiful. We'll back this one all the way out. We'll just see if we can push through that last 10 millimeters by gripping on 5 or 6 millimeters of that other drill. I might have to make a small extension. See how we go. We missed out by about 1 millimeter. Let's make an adjustment to the drill. Beautiful, we're through. And that's what we were gripping on to get through that last bit. Okay, one down, one to go. Yeah, so my original plan was to have the coolant feed port as close as I could get up the bar to somewhere about there, because what I wanted to do was cut a slot out the end here for another way to clamp a tool. That way I can utilise both ends of the bar. So what I was going to do is leave this one at 90 degrees, then the other one, cut the bar off at 30 degrees and do the same. So I think I can still do it. So we'll see how we go. Well, okay, that all went relatively painless. I'll get the other one in and I'll do that one off camera. Should be all, hopefully, fingers crossed, plain sailing as this one was. If I break the drill halfway through, I'll turn the camera on and we'll see. So yeah, let me get the other one out of the way and we'll bring you back. I like that. Okay, I think we better end this one here. We had a win on both shafts, or both our boring bars. Nice hole through them for the coolant. And that's just one example how you can drill a deep hole through a shaft or anything in that matter. You could, if you could go and buy the correct big long extension drill, but I bet you, pound to a pinch of pig shit, it would snap halfway through. Whereas the old homemade busted ass version, bit of silver solder, no problem whatsoever. So, but the thing to remember is if you're going to do any deep drilling, try and use a parabolic drill. Yeah, as we shown earlier in, it's got that very coarse spiral, so it can evacuate the chips a lot easier. More room for the chips as well. So anyway, we'll continue this in another video. What we probably will be looking at next is the holders, or the tooling to hold our bars on our tool post here. So anyway, cheers, thanks for watching, and yeah, hopefully see you, or you'll see me next video. Cheers.